Okay, we're going to look at quadratic inequalities. So first we're going to graph the equality and of x squared minus 4x minus 12. So I'm going to go ahead, looking ahead, I can see that we're solving for when the function is equal to 0, greater than 0, and less than 0. So I'm going to go ahead and use x-intercepts to graph. So I'm going to use the big X to factor, put my negative 12, my c value on the top, and negative 4 on the bottom. What multiplies to negative 12 and adds to negative 4? I get negative 6 and 2. So f of x is equal to x minus 6 times x plus 2, which means using zero product property, I get x minus 6 equals 0, and x plus 2 is equal to 0. So x is equal to 6, and x is equal to negative 2. So I have x-intercepts at 6, 0, and negative 2, 0. I have an a value that is greater than 0, so which means positive. So our graph is going to be concave up. So I'm going to go ahead and just sketch this in. Negative 2, add a line for 6. And I can also solve for my vertex. So my vertex would be negative b over 2a, comma, the coordinating y. So we get 4 over 2 times 1 gives me 2. And now we need to solve for f of 2. Okay. So we just plug it in. F of 2 is equal to 2 squared minus 4 times 2 minus 12. And that gives me negative 16, I think. 4 minus 8 minus 12. Yeah, negative 16. So this equals 2, negative 16. All right, so the vertex is going to be way down here. So this is a rough sketch. It's going to look something like that. All right, so using our graph now, when is f of x equal to 0? And f of x is equal to 0 at our x-intercepts. So at our x-intercepts here, so we get 6, 0, and at negative 2, 0, or when x is equal to 6 or negative 2. When is f of x greater than 0? F of x is greater than 0 when it's above the x-axis. So we have two sections, so we have to write two inequalities. So this would be when we are x values, so what's the domain of these green parts? On the left, it would be from negative infinity to negative 2, and not including 2 because at negative 2 it's 0, and from 6 to infinity. So here from 6 and beyond, and on the right from negative infinity to 2. Okay, in the middle part, we have the part of the graph that is less than 0. And so that's these x values right here. And that would be from negative 2 to 6. We write one inequality because it is that section of graph is all connected. It's one piece. Okay, so this is the part that we're really doing. We're solving algebraically for when the graph is greater than 0 or greater than a value. So here are your steps right here. Okay. So first we're going to find our boundary points by setting our function equal to 0, our y equal to 0, and solving. We already did that. That would be, let's rewrite this. What we really want to find is when f of x is less than 0. So we want when is x squared minus 4x minus 12 less than or equal to 0? Okay, so we start an inequality by making an equality. So we changed our inequality sign to an equality sign, okay, to find our boundary points. So I get x minus 6 times x plus 2, okay? So we get x is equal to 6 and x is equal to negative 2. These are our boundary points. That's step 1. Step 2, we're going to use a sign test to see when the outputs are positive and negative. So what I'm doing is going like so. You graph any x-intercept. So I'm going to graph 6 and negative 2. 6 and negative 2. This is because if you look at the graph, when is the graph going to change between positive outputs and negative outputs, or negative outputs to positive outputs? And that would be when the graph right here, when the graph changes from, or it has an x-intercept. So it has to cross over the x-axis in order to change output signs, okay? So what we're going to do is test a value that is between any of these intervals. So something that's less than negative 2, like negative 5, something that's greater than negative 2 but less than 6, like 0, something that's greater than 6, like 7, okay? So I'm just going to plug it in. I like to plug it into my factored form. So I'm going to plug it into here. Do negative 5 minus 6 times negative 5 plus 2. All I really care about is if the outputs are positive or negative. So will negative 5 minus 6 give you a positive or a negative? It gives me a negative. And negative 5 plus 2 gives me a negative. So what's a negative times a negative? That's going to give me positive outputs. Okay. The next place that we have to test is at 0. So again, I'm going to plug it into my factored form. Like 0 minus 6 times 0 plus 2. And we get 0 minus 6 is negative 6, which is a negative. And 0 plus 2 is a positive. So what a negative times a positive will give you negative outputs. So in this section here, the outputs are going to be negative. Last section to test, do 7 minus 6 times 7 plus 2. 7 minus 6 is a positive value, and 7 plus 2 is a positive. So positive times a positive will give you a positive output. So looking at the number line, I can see that the graph is going to go above the x-axis and also below the x-axis, like that. So thinking back to our original problem here, when is the function less than or equal to 0? Well, it's the yellow section. So my x squared minus 4x minus 12 is less than or equal to 0 when x is between negative 2 and 6, including those values, because it's less than or equal to. And that is how we do that. That's step 3. We write in set builder or interval notation. Or in interval notation, set builder notation, you can write negative 2 is less than or equal to x, which is less than or equal to 6. So either of those are acceptable. All right, let's do another one. When is x squared plus 7x less than negative 12? Okay, we're going to do the same thing, except this time we have a c value here. What we're going to do is make an equality, so our boundary points first. So x squared plus 7x is equal to negative 12. Next, solve the quadratic for the x-intercepts. Plus 12 is equal to 0. So we use big X to get our x-intercepts or quadratic formula. So what multiplies, I did that backwards. What multiplies to 12 and adds to 7? That's 3 and 4. So we get x plus 3 times x plus 4 is equal to 0. Using zero product property, x plus 3 is equal to 0, and x plus 4 is equal to 0. So when x equals negative 3 and when x equals negative 4, we're going to have zeros. Time to make our number line. Number line sign test. Okay, that's step 2. Okay, what values do we put on the number line? We put our x-intercepts. So I'm going to put negative 3, negative 4, and negative 3. I just leave lots of space. Okay. Test a value that is less than negative 4, like negative 5, negative 3.5, and how about 0? All right, I plug this into either my factored form or my standard form equations. I think factored form is easier. So I'm going to do negative 5 plus 3 times negative 5 plus 4. Does that give you a positive? Okay, negative 5 plus 3 is a negative value. Negative 5 plus 4 is also a negative value. So in total, those give you a positive. Next section. Negative 3.5 plus 3 times negative 3.5 plus 4. Negative 3.5 plus 3 is a negative. Negative 3.5 plus 4 is a positive. So a negative times a positive gives you a negative. Okay, lastly, 0 plus 3 times 0 plus 4. Let's see, those are both positives. So I get a positive out in the end. So what's the graph going to look like? It looks like above the x-axis on the ends and below the x-axis in the middle. Okay, so it's asking us, when is the graph, or if we go back to the original, x squared plus 7x is less than negative 12. So what you're going to do is you're looking to see, since I moved the negative 12 to the other side, it shifts our graph down. So we just look at exactly what our boundary points are at negative 4 and 3. Where is the graph less than the axis, basically? Okay, and it's at, so our original is x squared plus 7x is less than negative 12 when x is between negative 4 and negative 3. Do I use brackets or parentheses? I'm going to go ahead and use parentheses because we don't have our equal part. Okay. In the set notation, negative 4 is less than x is less than negative 3. And that's it.